Hi, 8th grade. This is a math video for lesson 11-6, which is all about something called similar solids. We have had an assignment like this in the past that dealt with similar figures. Those would be two-dimensional figures like similar rectangles or similar triangles or similar octagons, that sort of thing. But now they're three-dimensional figures, but the rules are very similar to this assignment. Imagine we have two cylinders. What we need to do is we need to look at the corresponding measurements of the two shapes. You'll notice I'm connecting the radius of this cylinder with the radius of this cylinder, and the height of the first cylinder with the height of the second cylinder. The rule about similar polygons says that if you can look at the ratio of the proportional or corresponding sides, and if those are equal, then you have similar figures. So in this example, let's see what 7.5 times 6 is, and let's see what 12 times 4 is. 12 times 4 is 48, and 6 times 7.5 is 45. Are those two numbers equal to each other? No, they're not. So instead of an equal sign, we'd have to put a is not equal to symbol. And what we're seeing is that the corresponding sides are not in proportion, so I'm going to write no. Another way to do this would be to turn this into a decimal number. This as a decimal number is 1.5, and this as a decimal number is not 1.5. I don't know what it is. Let's see, 7.5 will go into 12 once with a remainder of, what, 4.5. It would be somewhere in the neighborhood, I think, of 1.6, but I'm not sure. Let's take a calculator and actually do it. 12 divided by 7.5. Yeah, it's exactly 1.6. I got lucky on that one. So this ratio is definitely not equal to this ratio, so we're going to write no. The two figures are not in proportion. Let's try with this one right here. Here, the 9 is corresponding to the 1.5, and the 27 is corresponding to the 9. Is 9 over the top of 1.5, is that equal to 27 over 9? Is that equal to 27 over 9? Well, I could use the cross product method, right? This times this and this times this. 9 times 9 is 81. Is 81 equal to this times this? Which would be what? 40.5. No, they're not. So again, this is a no situation where the figures are not in proportion. Another, as I said earlier, another way to do this is to change this into decimal numbers and then compare the decimal numbers. In this case, 9 over 1.5 is, oh, it's not 4. What am I thinking? 9 divided by 1.5 is 6. And 27 divided by 9 is 3. So, again, no. Since these are not equal ratios, the figures are not similar. Let's go down here. Let's look at this one. What about 2 compared to 9 and 5 compared to 20? The base of the squares compared to the height of the rectangular prisms. Well, 2 is to 9. Is that equal to 5 over 20? And the answer to that is no, they are not. 9 times 5 is 45, and 2 times 20 is 40. So no, these are not proportional. Or if I went the other route, change this into a decimal number. Oh, rats, I didn't have that on there, did I? 2 is to 9. 2 is to 9 as 5 is to 20. Is 2 times 20 equal to 9 times 5? No, they're not equal. Again, this is 0.2 repeating, and this is, what, 0.25. So again, they're not equal if we change them into decimal numbers. Let's take a look at this one right here. about 5 is to 14 as 10 is to 28. Are those ratios equal to each other? Is this a true statement? Well, 14 times 10 is 140, and 5 times 28 is 140. Yay, we got one. Here's one where the shapes are similar shapes. Got one where the shapes are similar shapes. 5 over 14 is equal to 10 over 20. Let's try this next one. How about this 6 compared to the 4 and the 15 compared to the 10? 6 over 4, 15 over 10. 6 times 10 is 60. 4 times 15 is 60. Yay! Another one where the two shapes are similar. Now that we know how to do that, is there a way to figure out a missing measurement? I know 3 of the measurements, but I don't know the radius of this circle right here. Well, first thing, let's match up the corresponding sides. Let's create 2 ratios, and let's assume that the 2 shapes are equal, because in your directions they'll always say that. They'll say, assume that these 2 shapes are equal and find the value of x. Well, knowing that, it would be a matter of taking 4.5 times 8 and dividing by 6. 4.5 times 8 and dividing by 6. And when we do that, x would have a value of 6 in this particular case. Okay, let's do one more over here. Let's assume that this and this are the corresponding sides, and that the 6.3 is corresponding to the x. And if we know that, we can write 2.7 over 8.4 equals 6.3 over x. And we can solve for this x here. Well, what does that equal? I don't know. 8.4 times 6.3 equals that. 52.92 divided by 2.7. And I get a value of 19.6. My x is 19.6. Well, that's ugly. Let's do that again. My x is 19.6 in this particular case. Okay, 8th graders, hope this helps you.